All right. All right. Welcome back, everybody. This is the last class today. We are doing binomial expansion, and this is the last one. So if you go online on the website, again, you can go to the website, click on the notes section at the top, and then you will find there's a new circle, there's a new area down here for binomial theorem. So that's where you click on. Under binomial theorem, the first thing we'll go over is application. So application for this, what you're learning right now is a little early for this form of application, but essentially what happens is as you expand the binomial expansion, right? So for example, if you look at the expansion here, these are the coefficients that you get, correct? So all of these coefficients, if you plot them, you will actually start to get a curve that looks very much like this, okay? And we've talked about this before, right? This is the curve that we use to model a lot of different things. Like grades, for example, fall on curves like these. And so this is helpful because in statistics, these kind of curves are used very frequently. And it's very easy to get a curve like this using the binomial theorem because it's all algebraic, right? You just find a number and you plug it into here. So you can use a binomial expansion to plot what they call as a multinomial distribution. So binomial, for example, is used when you have heads or tails. So if you have two coins and you're tossing them, but a multinomial distribution is with the dice, which has 6 sides. So you can take your binomial expansion to a multinomial expansion and do it from there. So that's what it's helpful for. However, at the moment, the binomial theorem you're learning will not directly correlate to this application. So for your purposes, really a binomial expansion is really helpful for you to just learn to apply your brain in a logical manner. Because directly you won't be able to use it, but right now, to be able to apply your brain in a logical manner. So I'll go through a couple examples and you'll see what I'm talking about. So these are the main things that you should know, which is the theorem expansion over here, but this is already in your pure notes, okay? So you should just be familiar with how to use it. And this is the general term of an expansion. This one I think is absolutely necessary for you to memorize. I would really recommend memorizing this. And if you struggle with the memorization, then you can go here and just take a look at, for example, just take a look at this term here, and you can use that to sort of derive the coefficient or the general term. But if not, then this one is quite useful. And again, I'll show you when we go through the examples why it's useful, okay? I'm not going through the theory. You guys should know the theory by now. We'll just go through application today. One other thing that's very important actually is these common terms that need to be learned. So I would write these down in your pure notes. So definitely would write down the general term in your pure notes, this one, and would write down these common terms to be learned, okay? Again, this is on the website, so if you're following along, you can write these down from there. And learning these is important just because, for 2 reasons. One, it's knowing how this converts to this. Okay, so for example, let me do this right now and show you. If we take n and 0 here, then we get n factorial over 0 factorial times n minus 0 factorial, right? 0 factorial is actually equal to 1. So this was quite interesting. There's a cool video I can show you guys later for this one. So essentially what this becomes then is this becomes n factorial over n factorial, and that's why this is equal to 1, okay? Whoa, there's a ruler here. Interesting, nice. Yeah, so being able to do this is helpful for that, okay? Great. And just if you struggle with binomial expansion or understanding it, this tool right here I think is pretty darn useful. You have a general term, the binomial expansion of this, right? And this is the general term equation that I asked you guys to memorize. That's over here. Now, what you can do in this diagram or in this tool is you can change the power. So right now the power is 7, and I can change the power and it becomes 14. I can bring it all the way down to 5 and it changes it, okay? And then we're specifying what term are we looking for. So we're looking for example, let's say the 4th term. So one of the big things to know here is when you're looking for the 4th term, you are looking for t sub 3, interestingly. Like notice how the subscript here is r plus 1. It's really weird why they've done that, but you just have to learn this, that it's r plus 1. Therefore, you're looking for t3 plus 1. So for the 4th term, the denominator will be 4 minus 1, essentially. It will be 3. So this is quite helpful to know that part. Yeah, can everybody else see this properly or no? Let me do a quick poll. Is everyone able to see this clearly? Okay, the question is, are you able to see my screen clearly? Okay, all right, looks like you guys are. Okay, so this is the 6th term is defined by this equation, so 5 plus 1. And then it's really cool to be able to see the full expansion also. So as I change my value, you will see the full expansion also changes. And you can see, if you look at the coefficients, you can see how 7, 21, 35, 35, 21, 7, and 1, you can see how these sort of create a bell curve kind of graph, right? So that's how the binomial distribution comes about from this. And notice how 7, 0 becomes 1, right? 7, 1 becomes 7, 7, 0 becomes 1, and 7, 7 also becomes 1. So if you look at these rules here, you will see that n0 becomes 1, n1 becomes n, so 7, 1 becomes 7, and n becomes 1, so 7, 7 becomes 1, okay? So you're able to see the application of that. But essentially, you can use this formula to get this derivation. So again, we'll go through one example of this, just so you're familiar with this. But you can come on this tool and play along with it, and it's actually very helpful. The last thing you need to know on here is that anything, you can have A and B be anything at all. Like these can be imaginary numbers, these can be quadratics, these can be pi, like you could have these numbers be anything at all. And you just need to plug it into this formula to get the expansion. Okay, that's one of the more bigger benefits of this. So let's jump in and do the practice questions for today. And if this knowledge is sort of abstract for now, then hopefully this will translate to application. So these are the pure notes are here. Again, this portion is in your formula booklets already, so don't need to know this. This, however, is very important. The key again to remember is that for the kth term, okay, so for the kth term, that means like for the 1st, 2nd, 3rd, 4th term, et cetera, you are doing r is equal to k minus 1, okay? So for the 1st term, for example, k is 1, but r is 0. So this is 0, this is 0, and this is 0, okay? So for the 1st term, you do k minus 1 to get these r values. And similarly, for the 4th term, you do 4 minus 1 to get 3. So this is 3, 3, and 3. Okay, it's very important you know that. And if you're wondering, okay, why are they doing this r plus 1 business? Like why are they doing that? It's because if you look at this, in the 1st term, right? The 1st term, the power in the 1st term is wait, hold on, what is it? Yeah, if you expand on the 1st term, then you get, let's say 1st term, you get n r is equal to 0, right? 1 minus 1, or yeah, a to the power n minus 0, and b to the power 0, okay? So the reason they do minus 1 is for this 0 here, because the 1st term has a 0 power, okay? That's why they do this minus 1, because the 1st term has, the b term will be to 0 power, right? If you remember, if you look down here, then the x value has 7, but the y value is 0, right? It's multiplied by its x to the power 7 times y to the power 0. And it's because there's the 0 here that they do minus 1. Okay, so I want you guys to do this one out on paper. Just take 2 minutes to do this on paper using the formula above. The first thing to know is that this is equal to a and this is equal to b. So a is equal to x squared and b is equal to 3 over x squared. Okay, so if we use the formula, then let's use this formula together. Yeah, so we have the formula up here, so we're just going to use this to do the expansion, okay? So the first term is a to the power n, so that is x squared to the power n, which is 6, okay? Well, actually, I guess maybe this will be helpful. Let me write down n is equal to 6. Yeah, okay. Then plus 6, 1 times a to the power n minus 1, a is x squared to the power 6 minus 1, times b, which is 3 over x squared to the power 1, plus 6, 2, x squared to the power 6 minus 2 times 3 over x squared to the power 2. Okay, et cetera, et cetera. You just keep going. You just keep going from here. Okay. So this one's pretty straightforward. Notice how this term is just x squared. We can rewrite this term as something as a full expansion, which would be 6, 0 of x squared to the power 6 times 3 over x squared to the power 0. Okay, if we do that, then this becomes 1, and this also becomes 1, right? Anything to the power 0 becomes 1, and 6, 0 also becomes 1. Actually, when I applied to university, I applied to Cambridge, and in my Cambridge interview, they asked me what happens when you take a number to 0 exponential. So they were like, what is 5 to the power 0? So it's important for you to know that anything to the power 0 is 1. Okay, so this is, again, I'm not going to do too much of this. This is just plug and chug into an equation. We'll do ones like these. So this is where it gets really tricky, which is what they're asking now is if you have this equation, they want the coefficient of the x to the power 9 term. Okay, so let us simplify this. Let's say I have x plus 4 and x plus 5. Okay, I want the coefficient of the x squared term. Okay, what is the coefficient? Then you know that to get this, it's just this multiplied by this. Okay, so for you, this and this does not even matter because you'll only get x squared when you multiply x by x. And therefore, the answer is 1, correct? Okay, now, let's say I want the coefficient of the x term. Okay, so the coefficient of the x term is this times this, which is 5x, plus this times this, which is 4x. So the answer is 9, correct? So it's 9. So expanding this logic, essentially, imagine you were to do this expansion out for something as complex as this. And then you have to find the coefficient of x to the power 9. How do we do this? So I'll walk you through a process that hopefully will be helpful for you to do this in the future. So first you look at the simpler term, right? The simpler term means there's only a power of 1. This is more complex because this is power of 6, so this will be like a huge expansion, right? So we don't want to work with that one. So let's work with this one only. And then let's say, okay, something needs to be multiplied by 2. Let me come to a different part. Yeah, something needs to be multiplied by 2, and something needs to be multiplied by negative x cubed to get something x to the power 9, and something multiplied by x to the power 9. Okay, so the only thing you can multiply by a constant and get an x to the power 9 is x to the power 9, correct? And the only thing you can multiply with x cubed to get x to the power 9 is x to the power 6, correct? Anyways, we want something with x to the power 9 in the answer. And so the coefficient can either be x to the power 9 times 2 or x to the power 6 times x to the minus 3. Okay, so keeping that in mind, then what we can do is in this expansion here, in this piece here, we want the x to the power 9 term and x to the power 6 term. Okay, and what we'll do is multiply x to the power 9 by 2 and x to the power 6 term by negative x cubed. Okay, so whatever this term and this term is, we'll multiply, and that's how we get the coefficient of x to the power 9. And then we'll add these two numbers. So whatever number, we add it up, and that gives you your final answer. Okay, that will be the process. So let's do this process out then. So let me put up my answers. Yeah, okay. So the question is, what term has x to the power 9 in it? Okay, in this, like in this expansion, what term has x to the power 9 in it? And what term has x to the power 6 in it? Okay, and this is where the general term is helpful. So follow along here just for a second. So in this case, the general term, let's rewrite the general term. The general term will be TR plus 1 is equal to, remember, n is 6, right? So here n is equal to 6. So 6r times a to the power 6 minus r. Oh, actually, a, we also know a. A is x squared to the power 6 minus r, and b is 1 over x. 1 over x to the power r. Okay. Now that we have this, we want to solve for the exponent of x. So if we ignore this for now, let's ignore this for now, and let's only work with the exponents here. So this becomes x to the power 2 times 6 minus r multiplied by x to the power negative r, correct? This becomes x to the power negative r. Good. So simplifying this further, this becomes x to the power 12 minus 2r minus r. So this becomes x to the power 12 minus 3r. Okay? So what do we want now? We want x to the power 9 and x to the power 6 in that expansion. So we want when 12 minus 3r is equal to 9 and 12 minus 3r is equal to 6. Right? So in this case, r is equal to 2 and r is equal to 1. So we have a couple questions. Okay, good. So essentially we're looking for when r is 2 and when r is 1, okay? So now we can plug this back into this equation here. So this becomes t of 2 plus 1, which is 6, 2, x squared to the power 6 minus 2, 1 over x to the power 2. Okay, that's the left side. And the right side becomes t of 1 plus 1, 6, 1. Okay, these are your two coefficients. Move this to the center a little bit. Okay, so these are your two terms. And then what you do is, remember, if you multiply this, so you multiply t2 plus 1 by this term, right? That's how you get x to the power, that's how you get x to the power 9, right? Which is x to the power 6 times x to the power negative 2. So you multiply this by negative x cubed times this term. And this term here will be multiplied by 2. So you do 2 times t to the power 1 plus 1. Okay? And then you just add these two. So the answer is equal to negative x cubed t to the power 2 plus 1 plus 2 t to the power 1 plus 1. Okay? And you can just plug in the answers for this expansion into here and this expansion into here. Okay, good. All right. Let's do more of these. The tricky part is actually not that. Actually, there's two tricky parts in here which need to be learned. The first is this one here, which is knowing what two things will be multiplied, and the second is solving for r. Okay, so let's just do this together for this one. Let's do an easier one. That was a pretty hard one. We'll just simplify it down to be easier. So here we're looking for the coefficient of x cubed. Okay, so the general term, for this will have a is equal to 2, b is equal to 3x, and n is equal to 8. Okay, so the general term, looking at the formula, is tr plus 1 is equal to n, which is 8 over r, multiplied by a, which is 2, to the power n, which is 8 minus r, times 3x, which is b, to the power r. Okay, this is minus. So this is my general term. Now I want the term where x is cubed. So there's no x in here, right? No x in here. So I can just ignore this, and I can ignore this. There's no x in there because I want to find what r. So the only thing I'm really interested in is this one here, right? So 3x to the power r is x cubed when r is equal to 3, right? So t of 3 plus 1 equals to 8, 3, 2 to the power 8 minus 3, and minus, times 3x to the power 3. Okay? And now if you just expand this out, then you'll get the coefficient of x cubed. Okay, so this is just finding the coefficient of x cubed when you have only one binomial expansion, right? Above we had a multiplication. So let's build up to it. So this one should be pretty straightforward. Only one binomial expansion and only one term has x in it. Okay, so it's a direct application of this formula. Pretty easy. But I will make this more and more complicated, and what you will notice is that the process is exactly the same as it becomes more and more complicated. So the next complication is one expansion, but two values of x, okay? So again, in this, we're looking for the power of x to the power negative 21, okay? So very interesting, negative 21. So let's start with the same thing, general term. So a is equal to x, b is negative 2 over x squared, right? Don't forget the negative. N is equal to 12, right? So let's do general term is equal to tr plus 1 is 12r times a, which is x to the power 12 minus r, times b, which is negative 2 over x squared to the power r, okay? And here we want when the exponent is negative 21, right? So let's expand this out over here. So we can ignore this for now. So we have x to the power 12 minus r multiplied by negative 2 to the power x negative 2r. Okay, did that make sense? Let me make that actually one more step, if not. This is negative 2 x to the power negative 2 to the power r and there would also be an r here, but we can ignore these constants for now. So we're going to erase this out. Okay. So this becomes x 12 minus r minus 2r. Yeah. Now we want this to equal negative 21. So we do 12 minus r minus 2r equals negative 21. That's 12 minus 3r equals negative 21. So that becomes 3r is equal to 21 plus 12, which is 33. R is equal to 11. So in the 11th term, not the 11th term. When R is 11, the term will have an x to the power negative 21, okay? So then we come down here for R equals to 11. We do the same thing all over again. T of 11 plus 1 is equal to 12, 11, x to the power 12 minus 11, negative 2 to the power x squared, 11. And then you just expand this out to get the answer, okay? Okay, the question is, why did I cancel out the 12CR? Okay, let me slow down on this one and just explain this a little better. So we'll copy this here. Okay, so we have this, okay? All we care about here is the exponent of x, okay? So we care about the exponent of x and the exponent of x. So if let's take another example. If I have 5 times x squared times x cubed times 10, okay? All I want to know, actually let's also multiply this by x to the power a. Oops. A. That looks like a 9. Let's do b. Okay. What we're looking for is when is this equal to x to the power 10. Okay, that's what we're looking for. So we're really only working with the exponents here, right? So we really only, so the way to do this is you do b plus 2 plus 3 is equal to 10. You just take the exponents, add them up because they're all for x, and then you make them equal to 10. And so that's why it doesn't matter what this coefficient is here, because we're only trying to do math with the exponent, okay? And so for that reason, in this step here, we are solving for r. The aim here is to solve for r. And so to solve for r, we have to set up this equation here, which is the exponents on the left side is equal to this exponent that you need to search for. This is in the question. The negative 21 is in the question. They're asking you for it. And so you're only working with the exponents. And that's why these constants, I removed this constant because it doesn't matter to me. I'm only working with exponents, okay? Yeah, exactly. So you can ignore the coefficient and focus on the x value when solving for r. So when you're solving for r, then ignore coefficient, okay? When you have r, like when you're solving for coefficient, here we're solving, wow, I can't spell. Solve for coefficient. Here we have r, right? Here we already have r. And so therefore you don't ignore the coefficient. Here the coefficient is the most important part. You already know that the exponent of, like you already know that this becomes x to the power negative 21 because you've already solved for that, okay? Okay. Let's do more practice. Let's do one more. This one might make it easier. So this question again, same as the one before. We have an x squared term here and an x term here. Okay, so this is tricky because these two will multiply with each other in the expansion. So we want to see what is the coefficient of x to the power negative 3. Okay, so here we want something, so f of r equals to negative 3. Essentially, the exponents should equal to negative 3, okay? So again, I'm working with the general term because in the expansion, if we go all the way up, okay, in this expansion, only one term will have a coefficient, only one term will be x to the power negative 3, okay? Now we just need to find which term it is. Is it the first, second, third, fourth, fifth term, et cetera, et cetera. And that's why I'm only working with the formula of the general term to find out which term is it that is x to the power negative 3, right? If we go to if you go to this website, in this expansion, look at the answers here. Look how there's only one term that has the exponent of like y7, right? And only one term which is x6, and only one term which is x3, right? So we just had to figure out which term it is that has that, that coefficient. That's why I work with the general term. Let's come back down here. Yeah. So general term, again, same formula. T to the power r plus 1. So r plus 1 equals 2. Let me change this coefficient to a better letter. D. Okay. All right. So let's define A is equal to dx squared. B is equal to negative 2 over x. N is equal to 6. Okay, so this is A, this is B, and this is N. Okay, so using the formula, it's NR, so N is 6, NCR, then A to the power, so A is dx squared, to the power N minus R, so 6 minus R, times B to the power, so negative 2 over x, to the power R. Okay, that's the general expansion. Now again, we need to find when do these exponents here add up to negative 3. Okay, so just working with the exponents, we can therefore remove this term here. We can remove the d, we can ignore the d, and we can ignore these 2's, right? But for this one, let's say I don't ignore it. You guys will see what happens if I don't ignore it. So let's keep going. So we have 6 CR times, this becomes d to the power 6 minus r multiplied by x to the power 2 times 6 minus r. Okay, I've just expanded this here, has just expanded this bracket. So d is to the 6 minus r power and x squared is to the 6 minus r power multiplied by negative 2 to the power r over x to the power r. Okay, that's my entire expansion. So let's keep going. 6r times d 6 minus r. Simplify this becomes 12 minus 2r multiplied by minus 2r multiplied by x to the power negative r. Okay, so you will see how immediately, if I want to get the x to the power negative 3 term, I only care really about this term here, oops, about this term here and this term here, right? I don't care about these other terms, not about this, and this because there's no x term in this, right? Therefore, I just add up these exponentials. So we have to get this equal to something x to the power negative 3, okay? So I do 12 minus 2r, that's this term, plus negative r, this term, is equal to negative 3. Okay, that's what we're looking for. So let's do this math. This becomes 12 minus 3r is equal to negative 3. So 9 is equal to 3r, so r equals to 3. Okay, I've now solved for r. And then, so this was the first step, which is 1, solve for r, and now 2, solve for coefficient. Okay, let's do this one now. So now we know r, so just plug r. Plug r into general term. Okay, so 6, 3, and then dx squared to the power 6 minus 3 here, multiplied by negative 2 over x to the power 3. Right? It's just algebra here. And then you solve and you get the coefficient. Let's try and understand it this way. Let's say I have x to the power 9 plus 3x to the power 8 plus 4x to the power 7 plus 9x to the power 3 plus 4x multiplied by x plus Okay, in this expansion, can you tell me what is the coefficient of the x to the power 8 term? Let me make this complicated. Put 2 here. Okay, what's the coefficient of x to the power 8 term? Can you all put that down in chat? Can you do this for a second? What's the coefficient of the x to the power 8 term? Okay, so to do this, there's 2 ways we can get this. First is we multiply 4x to the power 7 times x, right? And the second way is we multiply 4x times 2x to the power 7. These are the only 2 ways to get, in this expansion, to get the coefficient of x to the power 8, okay? I love that people are making mistakes. So it's okay if you thought it's 3. That is correct. The coefficient of x to the power 8 is 3 in this term here. In this term here. But because you're multiplying this by a second term, the coefficients will change. So the only 2 ways to get this is this pink route and this red route, right? So let's do that out then. So the pink route is 4x to the power 7 times x, which becomes 4x to the power 8. And the red route is 4x times 2 to the power x, 2 times x to the power 7. So this becomes 8x to the power 8, right? So the answer is 8 plus 4 is equal to 12. That's the answer. The answer is 12. So these are the only 2 ways to do this. So now essentially what we've done now is, if so far you're with me, then what we've done is we replace this thing on this side with this term. Okay? This is what we've done. So if we go backwards in time, to get the coefficient of x to the power 8, we needed the x to the power 7 term and the x term, right? Or actually, let me write it this way. Term and the x term. These are the 2 terms that we needed. So this is the x to the power 7 term, and this is the x term, correct? Because the x to the power 7 term was multiplied by x, and the x term was multiplied by x to the power 7, okay? So now, let's say we replace this piece here with this. Then to find the coefficient of x to the power 8, from this term, from this expansion here, we need the x to the power 7 term, and we need the x term. All right, and then what we can do is then put that over here and over here and get the answer. Does this approach make more sense? Did this explanation make more sense? Okay, all right, good, all right. In that case, I'll start with this. So what we have done now is 3 big pieces, which are very important for the binomial step. If we go to the top, one thing we've done is expansion, right? 2, we've done solve for R, and 3, we've done plug R to solve for coefficient, right? Now, these other pieces, what we've introduced here is, in this example here, where did we go? This is helpful now. To have this strong base is helpful for questions like these. So in this question, so far we've only been working with this, okay? We've been only working with that. Now what we're doing is we're multiplying this by another term. Okay, and then we're looking for the coefficient of x to the power 12. So this is tricky, and this becomes tricky because you now, to figure out x to the power 12, there's one more step. And that step, let me explain the step to you very clearly so you know how to do this in the future. Another way to write this is the first term, which is x squared plus 3x 6, multiplied by this term here, which is 1, okay, plus multiplied by this term, which is negative 3x cubed. Okay, does that make sense? What I've done here is basically what you do in expansion. So if you have a plus 4 and b plus 3, right? You do an expansion, right? So this becomes b times a plus 4 plus 3 times a plus 4, right? That's exactly what I've done over here. It just looks scarier. So the same thing has happened. Again, you don't need to know why I've done this or how I've done this. It's just, you'll see how this is helpful in that now, if you want the coefficient of x to the power 12, you need two terms, right? This is the first scenario, and this is the second scenario, correct? So in this case, what you're looking for is, well, in the first case here, you want the coefficient of x to the power 12. And in this, you want the coefficient of x to the power 9. Why? Because x to the power 9 times negative 3x cubed becomes negative 3x to the power 12, right? You add these two powers here. And so that's why you are looking for x to the power 9 in this expansion. In this case, we're just multiplying it by 1 in the above case. So in the above case, you're just looking for the x to the power 12 because you're just multiplying it by 1. And essentially, this is all it. Now you can just piece this together to do something more complex like this. So I'll give you a second to think about how you would approach this one. Using what we've learned so far, how would you approach this one? Okay, let's just do this together actually. So this is the more complex term, right? And this is your simple term. So we can rewrite this out and expand it. So 1 plus 4x to the power 5 times x squared minus 2x plus x, which becomes minus x minus 2. Okay, so now we just need to see which of the terms, when multiplied by these things, add up to x2, right? So there are three scenarios. So let's use which color? Okay. Scenario 1, 2, and 3. Okay, so 1, 2, and 3. So in scenario 1, you're multiplying x squared by something. Scenario 2, multiplying negative x by something. And scenario 3, multiplying negative 2 by something. Okay, so what are you multiplying it by? Well, in this case, from here, we would need a constant term, right? Multiplied by constant term. Here, the x term, and here, the x squared term, right? So the terms that we need, so we need three terms, the constant term, the x term, and the x squared term. That's what we need from this expansion over here. So then we take the general formula again, which is, what's the general formula? Okay, that's the general formula. We want to solve for r. We want to solve for r when the exponent is equal to 0 for here, right? Here, exponent is equal to 0. The x exponent is equal to 0. So I'm going to just do 1 because we've done ones like these. So this becomes 5r a, which is 1 to the power 5 minus r, times b, which is 4x to the power r. Okay? And we want when x is equal to 0, when something which is x to the power 0. So we do 4r xr is equal to x0. So when r is equal to 0, essentially r is equal to 0, right? We just solved for r equals 0. So then the general term becomes t to the power 0 plus 1 equals to 6, 0, a, which is, again, 1 to the power 5 minus 0 times b to the power 0. So we know what 6, 0 is, right? 6c0, this becomes 1 times 1 to the power 5 times 5 times b to the power 0 is 1. So this is 5. So this piece goes into here. So we erase this and write down 5. Okay? Now we just have to do this again for the x term and for the x squared term. So this is all I have for you guys today. On the website, there is a worksheet. If you go down to the practice questions area, there's a worksheet with, I think, about 30 or so questions on this. So this is complicated, I won't lie. This is not easy. It's not easy to do. It's also not easy to teach. It's very difficult to sort of put this in a simple way on paper. But I hope this breaking it down into these smaller steps is helpful. All right, let me send you out with this nice music.